How are you? Very well. So you see the one squiggly line in the sketch notes? Oh yeah, they're by registrations. I'll be able to call that. I don't think.
All right, might as well get started right on time. We have a pretty full room, so if anyone comes in, they can find a seat and we'll get started with the introductions. So, welcome everyone. Thanks for coming out right before lunch here. Can everyone hear me okay in the back? Mic's okay? Okay. So this is Thinking Like a Hacker, and my name is Chris Manalina. I don't really want to get into too much about myself because that kind of stuff's boring, but if you do want to find me after the talk, I'm C. Madalena on Twitter, Chris Madalena on GitHub, and basically, you hit me up on Twitter, you can get a hold of me pretty easily. It's also where I am most other places. Just the quick thing about me that's pretty relevant to the talk is I'm a security consultant for GuidePoint Security and a penetration tester. These job titles are kind of interchangeable a little bit in what I do. I actually get hired to visit office buildings, sometimes on site, sometimes remotely, and either it's trying to break into a computer network, trying to whether it's from the external side, or maybe I'm given some kind of foothold inside, like they give me a laptop, so we act like I stole a laptop, or we play out some kind of scenario where I see how far can I get before they catch me, or even if they do catch me, how far could I get with their security controls. And if we have some time, I'll share maybe some stories actually just from about my last 72 hours where I was actually across the country and was breaking into an office building. So I have kind of an interesting job, but this talk is also kind of inspired by and kind of a continuation from my talk last year. So I'm really happy to be back for my second year speaking at CodeMash. Last year I spoke on what to expect from penetration tests. If you attended that talk, awesome. Glad to have you back. You don't have to have seen that talk to understand this or anything. But that is up on my GitHub if you're curious about it. It's on YouTube as well. But that dives more into the methodology and some of the tool sets that I use and people that do my job use and how they're used. So if you've ever seen a pen test report or something that came out of it and didn't really know where it came from, that was the talk that hoped to help you introduce to what kind of work goes into those reports and that testing. What I want to talk about today is typically what kind of in the security field we refer to as red teaming. Red teaming actually has a really interesting history, so I wanted to share it with you for a minute. If you've ever heard the term before, it actually evolved from the Catholic Church, of all places. So the Catholic Church had an interesting problem a long time ago. They had too many saints, and they needed a way to try to vet the saints before they canonized them. So they came up with a revolutionary new position, which they just referred to as the promoter of the faith, which is basically a canon lawyer. So this was a guy that had to look at the would-be saint and try to pick them apart, find character flaws, problems with anything that might tarnish their reputation that would not make them a very good saint. And this wasn't really something anyone was doing, and it's also kind of a dirty job. You have to look at someone that maybe is a really nice person, maybe they do great things, but you have to find that problem with them. You have to kind of pick them apart and be real nitpicky about it. And they became known as the devil's advocate, which obviously you've probably all heard the term playing devil's advocate. That's where that comes from, is kind of trying to be contradictory. Their whole job was, everyone wants to make this person a saint. I'm going to find the reason why they shouldn't be a saint and make my case for why that's true the case. Many years later, this was actually adopted by the US military during the Cold War. And this is where we start getting red team versus blue team from. You hear a lot both in common media today and like video games like Halo. The concept of the red team came out of the Soviet Union. The US military wanted a way to do some tabletop exercises. And a few people said, well, we can't just have the same, military officials across the table from each other trying to figure out what would the Soviet Union do. We want someone who can do real critical thinking, try to actually play the role of the Soviet Union, respond like we think they would, really adopt that mindset and look for flaws in our plans and how we can go, kind of play off each other. So they went out and they had people that they had kind of earmarked as like, this person was a really good critical thinker, this person has interesting ideas. They brought those people together and had them work for a period of time as the red team. And they would kind of play off the blue team, which was the other US military officials. And so they would say, well, we're going to go do this. And they would say, well, we would respond this way as the Soviet Union. And maybe they were right, maybe they were wrong. But this actually changed the Cold War enough that they founded the University of Foreign Military and Cultural Studies, which is basically the military's red team college. You can go there and they'll teach you critical thinking, but now they call it red teaming more officially. It's just the idea of learning more about the enemy and what they're doing and their capabilities, what they're thinking, and learning how to adopt that mindset to think like them. And today, that has evolved into kind of a whole industry. You can get red teaming from everything from like corporate war games to someone coming in and working with your executives to say, all right, your competitor just released a fantastic new product that is just like yours but better and cheaper, what do you do? And things like that. But what I do and what I want to talk about today is from the kind of information security side of things. So my job, a lot of people view it as breaking things. I come in, I break a bunch of stuff, I knock things off the table and I say, look what I did. You should have stopped me from doing that. But the way I see it is actually trying to do much like the Catholic Church has promoted the faith, or the U.S. military red team is coming in, finding misconfigurations, little oversights, little problems, pointing them out, saying, I think you forgot about this. And then I get to write up a big, nice report. And probably 90% of my job is writing reports. And I get to then make my case. If here's why you should fix that, here's why you should pay the money to do this a better way. But the kind of fun part about my job is then to convince them. I often don't have to just look at this academically. I actually get to carry out those attacks and do those things for real to show them what can happen. So, quick break for water here. So the main topic for today is the mindset that goes into this. Basically, this is a mindset that we would like to have both the defender and the attacker have. It can be hard to think about this way all the time. In fact, if you do that, you'll just end up nitpicking every little thing and probably never get any work done. But the point is being able to go back and forth, which is the whole point of going back to how the military does red teaming. Those people they brought in from different branches, different departments, and said, you are now the red team, they disbanded afterwards. They didn't stay the red team. They went back to doing their normal jobs. And the military does this a lot. They call them tiger teams. They're supposed to be quick and agile like tigers, and it sounds cool. But they bring in people from different departments, different areas, and say, you're all working together now. You all have a different skill set. Here's what we want you to do. They have some deadline. They get it done. They disband. They maybe never work with each other again. So you don't necessarily have to adopt this mindset all the time, but we're going to go over some things that are good just to keep in the back of your head and to understand. Really the basic thing about this mindset is just being good at asking questions. Don't assume anything. Saying think outside the box is really cliche, but it's true here. Don't look at just what you think the rules are. Look at how those can be broken. And we'll get into more of that in a minute. But the key thing here that I like to think about is just looking at things plainly. Look at it in its pieces. Don't look at it as a whole. If you're looking at an application or a process for something, look at how each piece breaks down all the way down to the little details. Like, don't just look at a website, look at the fact that it's using HTTP and how can HTTP be abused in this case, or what are the protocols that are underneath of it. Actually, I saw this yesterday. I had never seen this before. This just this frame from The Simpsons that kind of purposely encapsulates this. This is basically everything we're talking about. You see something, you say, oh, that's how that's supposed to be used. Who cares? Nothing's going to stop you from using it another way. So if something tells you to keep out, it's not a cop, it's just a sign. So hopefully he's in this room somewhere, but I think Charles will get a kick out of this. So last year, Jimmy Bird told me, you're just a glorified QA tester. And he's totally right. I agreed with him then, I agree with him now, that is what I do. I do quality assurance. And we'll get into this a little bit more in a couple of slides, but typically the QA engineer, they have their test cases. They look at things, they make sure this thing works. If you make a little mistake on the keyboard, you typo something, it doesn't totally break everything. This looks good, I need to move on to the next thing I need to QA as part of this application. But as an attacker, I have all the time in the world. So I can come in there and I can break it, and then I can try to figure out how it would be fixed or what can happen when it breaks. And one of the key things is that I'm looking for what you maybe forgot. It's not necessarily that there's something wrong with your code or that there's something wrong with your network architecture. It's just that you forgot something. Or something was stood up over here, or there was a change was made and then was never touched again that is causing a problem. And so my whole job is trying to hunt down and detect those little things. And that's a big part of this mindset, is being able to look at things differently and just kind of drop the assumptions, drop the context of what you're looking at, and see like, all right, well, what is this code doing when you're doing a code review? Or what is this network traffic doing? What is this application doing? And don't assume like, well, we know it's talking to this database to do purchases. Just drop all that and look at exactly what it's doing and see if you can find out something weird. Maybe you start asking like, why is it doing it that way? And that's how you start to find problems. So kind of one of the basic principles of this, and I know this is this is kind of a networking example, but I think it's something everyone at this conference can understand. One of the basic ideas of hacking, and this is sort of an attack, if you can call it that is used pretty often, is using the expected idea of how something should be used in an unexpected way. So for example, we all know, or I'm going to tell you now if you didn't know already, that port 443 is HTTPS. We're told that's what you use it for. It's HTTPS. All of our browsers know that if you connect to 443, you should expect HTTPS traffic, etc. There should be a website there. So cool. Well, that also means that if I look at it from a broader perspective, that means that at every one of your jobs, your sysadmins, your network architects, have to allow 443 through the firewall. Because you all want to go to websites, you want to check Google, you want to search for things. So 443 is going to be open if I want to be able to get something out of the network. But let's say then there's security monitoring that might look for weird things on 443. Well, that's okay, because nothing stops me from encapsulating all of my stuff into HTTPS traffic. So now, when I am actually working inside of a network and I want to get something off the network, or I want to communicate with one of my own attack servers, I can just talk to it on 443, encapsulate everything in HTTPS, and as a nice added bonus, because it's HTTPS, it's all encrypted and you can't see what I'm sending out. And it just looks like website traffic. So we took something that you would think, like, well, that shouldn't happen. We should be able to stop that. But that's really difficult because it's working exactly as designed. We're just using it in an unexpected way, a way that's not necessarily meant to be used. So just you see in the movies, like, oh no, the firewall's encrypted, we can't get out and all this. It's usually mostly just looking for ports that might be open and finding the right one. And typically there's a few that are almost always open on networks, especially where employees will have their workstations. Things like that. And so at this point, I just want to bring up Shannon's maxim. If you've heard of Claude Elwood Shannon, he's considered the father of information theory, and his maxim is just the enemy knows the system. And kind of the larger version of that is that he says that one ought to design systems under the assumption that the enemy will immediately gain full knowledge of them. So the reason I pose this to you is just always assume that any attacker, anyone that's looking at an application you write or a system you design, that they are at least on equal footing with you. They will figure it out. They have all the time in the world to poke at things and figure things out. They might not have access to the source code, but they can probably start making some really educated guesses. Many people who out there would actually want to do harm, or even if they're just trying to help you, like a penetration tester, they are usually on at least equal footing with the sysadmins and the developers behind the applications. And if they're not at the start, they usually gain that knowledge over time. So I want to start going through over some examples and send me some good vibes, because I did realize it was Friday the 13th, like 15 minutes before we started, and I have a bunch of live demos. So we'll see how that goes. So getting started, I want to look at one of the major questions I often get is just like, how would you ever find that? I stood up something on DigitalOcean or Amazon Web Services. I just have this server out there. I know it's probably vulnerable, but I mean, it's out there in on AWS. You're never going to find my EC2 instance. Well, the thing is that, and this sounds crazy when you first hear it, but that the internet is constantly being scanned. Everything on the internet is constantly being scanned. The idea of security through obscurity just really doesn't work anymore. I mean, security through obscurity is basically the total opposite of Shannon's maxim of the enemy knows the system. We have the tools now. There's tools like MassScan, which is just massive scanner that is actually engineered to quickly scan the entire internet. All the available IP space to scan it for various different types of open ports, different service banners, things like that, to hunt down specific services that are running out there on the internet. And then not only that, I mean, we can do things, and I'll go over some examples for you. Searching social media, finding files on web servers that aren't actually even mapped, anywhere on the website, et cetera, et cetera. And a couple of the major ones for this would be Shodan.io. It kind of sells itself as like the search engine for the Internet of Things, for anything, or for refrigerators, like it is up here. But what they do is they scan the entire internet and they catalog it. It's searchable. You can get on there, and I'll actually show you some examples in a second. But you can get on there and you can search for a port number and just see everything on the internet that has that port number open in the last couple of days when it was last scanned. And then Census.io from the University of Michigan is a research project that does a very similar thing. It doesn't have a lot of the flashy reports and graphics that Shodan does, but same idea. You can get on there, you can search for businesses by their SSL certificates they're using. So, for example, if you have a test certificate that you create for QA, you stand up something on a cloud service, and it's not even tied to your business at all, but you're using an SSL certificate that has that common name, it can be found on Census or Shodan and tied back to the company. So that's how a lot of attackers will start doing reconnaissance. If they're targeting a specific company or a specific person, you can start tying people together from things that are left behind that you might not realize are available and actually searchable and indexed on the internet. So one example was last week, I wanted to find a cool screenshot for you guys, because one of the big things you can search for on Shodan is VNC, which is, if you're unfamiliar, it's just remote desktop protocol. And for a long time, it was by default, or there was a flaw in it that allowed you to bypass authentication. But you can also just configure it to allow anyone to connect to it, which seems crazy, but some people do that, and probably with the idea that no one's ever going to connect to this because they don't know where I am. But we can search for that on Shodan and find it. So right on the first page of results, I found a neat little coffee shop in Campinas, Brazil. And I know it's a coffee shop because it was their cash register. And so what probably happened here was that maybe they had a vendor, maybe VNC is installed because the vendor needs to connect to it to fix things sometimes, and maybe they could have set a password, but like that's just a pain. Then we have to tell the vendor what the password is. I have to let the tech know, and then we have to turn it off. And let's just turn it on. They'll connect to it. We'll turn it off later, and they forgot. Like there could be a totally valid excuse for this, or maybe that register has just been totally owned, and there's just people have been connecting to it on VNC to do stuff with it. Who knows? But it's there for you to go and connect to, and you could. It'd be bad, don't do it, but you could connect to it and probably start ordering people coffee. So things like that are out there, and it's worth being aware that these can be found. Like I found this literally in like 30 seconds, just totally stumbled into it. Then I want to touch on this as well, because this has been in the news. I've seen it on a couple of the whiteboards and stuff. And kind of coincidentally, after I made this slide, a lot of the news of the ransomware with MongoDB came up. But after hearing a couple things this morning, which I won't get into specifics, but if you want to, I tweeted about it this morning if you want to see the details. But I heard some people talking and stating that this was more of a MongoDB problem. That it was MongoDB's fault that people had unauthenticated access on their servers. Because in this case, we can see that Shodan has, they'll even list like top countries and everything, so you can see that top country is easily the United States with open MongoDB servers. But a big reason for that is the top organizations: Amazon, DigitalOcean, Amazon Technologies, Microsoft Azure. All of those are the top, because those are just cloud services. People are spinning up these Mongo instances for their apps, for some testing, and then they just don't actually lock them down because they probably figure no one will ever find them. In this case, I actually used this example last year and on a different server, and I found it again with a very similar problem. They had an open database and someone just went in and deleted it and said, well, I deleted this because you didn't password protect your MongoDB. So who knows what was on that, but it's gone. But now if you've seen the news, obviously there's around roughly 100,000 of these indexed on Shodan right now. And the last time I checked, it was like 27,000 had been encrypted with ransomware. So they're now actively going out there, finding these and connecting to them and trying to destroy the data or hold it for ransom. And it's not necessarily a MongoDB problem because they actually fixed it. It was an issue. It was a dumb mistake on their part to have unauthenticated access on all network interfaces by default. But they fixed that in 3.2. But you can, what you can also find on Shodan is that many of the most common versions are like 2.2, 2.4, 2.6, and 3.0. So people aren't updating Mongo, they're not updating the configs, and also when Mongo fixed that, they released a notice that, hey, this was a problem, we fixed it, but we're not going to mess with your configs because that could mess with what you're trying to do with it. Please go change it. How many people actually did it? So it's worth noting just that when you see those things, you hear about those things, checking your settings because the stuff can be found. I just wanted to mention that because I was hearing some conversations like, oh, that's a Mongo problem, just don't use Mongo. You could misconfigure a lot of database software.
You can, but that's still insecure by default.
Oh yeah, no, it definitely was there. They fixed it though, so to their credit, it is not that way anymore. But I mean, there's plenty of other software out there that people have configured to be on. They turn on remote access and they forget to password protect it or don't set a very good password. Last thing to touch on just for discovery, because the idea of like things being misused from their kind of intended purposes is just Google search results. We can actually, since Google's out there indexing everything, you can go and ask Google using some of their keywords, give me exactly this. So for this example, I used the just file type modifier, and I said just give me only file type XLS. And I want it to contain, because Google will actually open up those documents it finds and index those, and just like it does a web page, I want you to only give me file type XLS that has a username and password in it somewhere. And you get back pages and pages and pages of spreadsheets of passwords and usernames. And like in this case, it probably was put here by mistake, put it in the root of their web directory, and Indeed that was full of usernames and passwords for their vendors. But you can find all kinds of examples of this. You can do file type key, start finding SSH keys out there. And of course, you can also use things like site and in title to narrow it down to exactly like just a certain company, just a certain person, like their personal website, things like that. So also worth remembering that if you accidentally leave something in a web root, or it's, you get back a pen test report and someone like me tells you like, you have a browsable web directory, you might not want that. And just because there's nothing in there today, but just be mindful of that. This is why. Because Google might pick it up at some point when something accidentally does get moved into that directory. So once it's found, often the next question is, well, how did they break it? How did that happen? So a big part of what an attacker will do is then they have to actually chart the unknown. They don't know what your application does. They don't know what the website does. They don't know what it was coded in or when it was created. They know nothing about it. It's totally, usually like for pen testing, we call this black box. I don't know what's in the box. I'm just told, get into the box. So there's lots of ways we can do this, including what we just looked at, discovery, looking at what ports are available, scanning things, seeing what's available. Ports and banners can give us a lot of information. Version numbers are in banners for services, things like that. Even if it doesn't return a banner, I can connect to it with a number of different tools and just start sending it input to see if it comes back with something to let me know what kind of service it is. And and that's usually referred to as fuzzing or sometimes brute forcing. There's a little bit of a difference here. Like fuzzing, usually you're providing like invalid or random data, sometimes valid data mixed with random input, just to seeing like what the application does. Does it crash? Does it start spitting back errors? Because especially one of the big things with databases or similar things that you do database queries, you give me back like a nice big fat like MySQL error, and with the query in it and everything, that can be a gold mine for an attacker. So we just want to see what can we break and how does it break. And then brute forcing is kind of the same thing, sending it a lot of data really quickly, but usually it's focused on like passwords. I have a username, I don't have the password, let's keep sending it the username and passwords from a list until we get in. So to call it, to build something from here at CodeMash, kind of the joke that he's become like Twitter famous for. This is kind of the difference that I see like between like just doing a QA, a QA assessment and an actual attacker. Like QA, they have their test cases. They order a beer from the bartender, see what happens. They order 0 beers, make a ton of beers. They order random stuff. You're like, oh, you accidentally type out something. Like, what did the bartender do? Like, okay, cool, my test cases are done. The bartender doesn't crash. The attacker comes in, orders a beer, and then sees how the bartender responds. And then they look at the request, like exactly how did we ask for the beer? Was it like beer equals 1 in a GET parameter or something like that if it's a web app? And then how did it respond? What was in that response? Was there any interesting like JSON parameters or something like that I can mess with? And then they might just start sending all kinds of garbage, like fuzzing data, fuzzing for cross-site scripting or SQL injection, things like that, until they maybe get a hit. Things that maybe aren't necessarily part of the QA test cases. One of the ways this is done, because I know this came up as well while talking about the CodeMash CTF here, was, well, how do you find this stuff if you don't know where a memory address is or how it crashes? Well, there's fuzzers that do this for us. Basically, if it can be automated, it probably will be. It has been. And in this case, there's fuzzers such as American Fuzzy Lock, which is named after like this cute little guy. And you just give that a binary executable. It starts sending it all kinds of data, just to see all the different code branches, see where it flows, and then once it learns more about it, starts actually applying intelligence and saying like, well, I know it crashed this way, or I know it responded this way when I gave it this. What if I tweaked a little bit? And the idea is that when it finishes, we have basically a map of every way the code can flow with different types of input. And there's fuzzers for, like I said, like binaries and executables. There's things like burp intruder for web applications that are spidering and trying to test web forms. Same thing with like OAuth, Z attack proxy. And actually, I want to take a look at one of the things you can get from fuzzing, which is cross-site scripting. And if you've ever seen a pen test report, or you've seen examples of cross-site scripting, or maybe you've just seen a computer science class, this is often what you see. Like, look, we made alert 1 show up. Like, isn't that crazy? It's really not. It's not all that impressive. It's also not all that scary. So it leads to, sometimes people will ask me, or I hear them wondering why cross-site scripting, when it just makes a pop-up show up on the page. Why is that like number 3 in the OWASP top 10? Well, again, if we look at it piece by piece, JavaScript runs on the client side, not on the web browser, so that also makes it look not that scary, right? You can't hurt my website with JavaScript, but it runs on the client side, and it runs in the under the client's browser, so we can do stuff against the client. And JavaScript can do way more than it probably ever should. We can play sounds. We could check the laptop's battery status if we wanted to. We could also steal cookies. We could redirect the browser somewhere else. We could replace all of the hrefs in the page to some other href that we wanted. We can capture things from the webcam. It would require them to click, accept that they would allow the page to access the webcam. But if this was on a page like some sort of video conferencing software like a WebEx or Zoom that already has their permission, they might not think twice about clicking yes to that permission.
You can overlay a transparent div with a high Z order.
Yep. So we can actually fit all of that into one cross-site scripting payload, which is, this is one thing that I don't think gets talked about enough when cross-site scripting comes up, which is Beef, the browser exploitation framework. And I want to show you a demo of this. What Beef does is it's a Ruby script that I actually have it running here. It has a RESTful API. You connect to it, and it hosts for you a hook.js. You use hook.js as your cross-site scripting payload, and it'll hook the browser. And then we can do all kinds of things with it. And I'll show you an example. Oh, you know what? I totally forgot about this. This was some of the showing examples I found just before the talk. Here's a guy's desktop. I like that he had exploit.jpg down here. And he also really likes this jeans ad. That was weird. And here's just some guy's desktop, all VNC unauthenticated. And then you can also do reports on Shodan, I wanted to point out. So if you are curious about things like MongoDB, I did, now I can share this with you or tweet it out or something if you want. I saved a report, because I do have access to the API and account, so I did create a report if anyone is curious for the exact stats as of half an hour ago on the current open status of MongoDB out there on the internet. It has all the top versions as well as the top domains where they're hosted. But let's take a look at Beef. So this is the framework. I'll make this bigger now. And here is Mutility. It's just a vulnerable web application that OWASP maintains out there as part of their broken web application project. But we're just going to do some cross-site scripting here. Say, let's hook this browser. And we should get this straight. There we go. So we've executed cross-site scripting. We've tricked our user into running our malicious link or what have you. And now we have access to their browser. And we can see things like, okay, this is Firefox version 50. It's on a Mac. Here's browser plugins that are installed. And this already starts telling us a lot about the user. Okay, well, we can see that they have Citrix. A couple of things maybe this isn't their main. I don't know why it does that. Suddenly, people are really liking tweets that I put out. Hey, he's tweeting. Hi, Wolf. So we can already see a bunch of information, but that whatever. That's fine. Let's go into commands. And so we can start doing all kinds of things. And one of my favorites are just under the social engineering. And Beef has what they call, and I think this is a typo, because I always called it petty theft, and it wasn't until I started putting this demo together that they call it pretty theft. So I don't know why, but the idea behind, I'm going to call it petty theft. The idea behind petty theft is that we're going to pop up an image and basically a form that they can't click off of until they log in. And we can say hey, let's steal their Facebook account, and we just execute it. Wolf. I think Wolf is just going to troll me with tweets. But there we go. So through cross-site scripting, and again, they can't click off of it. They, we can't do anything. I have to. Oh, I guess I do want to stay logged in to Facebook. So we log in. And back here at the Beef control panel, we see what the user typed in. So we can do all kinds of things like this. Everything from fake notification bars. Here we can execute that one. Oh look, there's a plugin wants to be installed. Maybe I should do that. So and you click that, and it would download the plugin and ask you. It would execute it exactly like if a plugin was trying to be installed. All very clever little ways that through JavaScript we can trick the user into thinking they're interacting with their browser or a website that they trust, just by accidentally having clicked on or encountered maybe even persistent cross-site scripting that was present on a page. And then as my last one, this one's kind of funny, because we all love Clippy, right? We could abuse our poor victim with Clippy popping up constantly on their page. And then if we click not now, go away Clippy, he just comes back in 5 seconds. So there he is. No, go away. So we can do terrible things like make Clippy show up on your screen with cross-site scripting. But the point is that JavaScript probably does way more than it should be allowed to do in a browser. So even things like cross-site scripting that at face value often isn't described in any way that's super scary or doesn't sound all that special, but it might not impact like your business or your application explicitly, but if there's cross-site scripting, I might be able to send them a link, or someone more malicious might be able to send them a link to have them click on things and download stuff that they really don't want on their computer, or have cookies stolen, session IDs stolen. Really, the only limitation is what is available in their browser. So a quick recap is, so we've looked at discovery, how attackers find things. We looked at how things can kind of be mapped out with fuzzing and abused. But I want to also then talk about, well, what happens if we actually start interacting with the computer itself, like the actual physical thing. What if I have physical access to it? So I want to talk a little bit more about like the actual red team assessments that I do and some of the tools that we use, and applying some of the same mindset. So one thing that we can do is have a lot of fun with RFID. You probably all have RFID tags, like on, attached to your work ID or something you use to badge into a door at work. So again, kind of like the problem with DVD players when they first came out years ago, DVD encryption was cracked. Well, how did that happen? Well, there was basically a major flaw in what they wanted to do. They wanted to encrypt DVDs so you couldn't just take it off the DVD and give it to all your friends or torrent it. So they encrypted it. But then they had a problem. Well, we want people to actually be able to play them on a DVD player, so we have to give all the DVD players the encryption keys, or the decryption keys. So that meant that for the cost of a DVD, you had the encrypted media, and then your DVD player had everything you needed to decrypt it. So people just took apart a DVD player, got the decryption keys, and that was the end. They looked at it in its pieces, not going like, oh, that's the only thing that can decrypt this stuff. That sucks. They just said, oh, well, that can decrypt it. Let's figure out how it's doing it, and just then put it on our computers. So we can do the same thing with RFIDs. Those little like HID cards that you probably have. So the way they work is you walk up to a door, you put it up against a scanner, and the door reads the bin number off the card and says, yeah, you have access to this door, and clicks open. So that means that it doesn't have to be just that door. I can walk around with like a garage reader. Like, I wish I actually did this a few days ago. What we have is if you ever go to like a garage that has a HID reader, you see those big like gray squares that are about yay big, and they're around $400. You can buy them on Amazon, and it's pretty easy to mod them to, instead of sending that onto a computer system to unlock the door, just sends them into an SD card and runs off battery. So I walked around with one of those in my bag, and as long as I'm within 3 feet of someone's card, it'll probably get a read. And it's just working just like the door reader. It says like, oh, what's your bin number? Reads it off, and just instead it goes, cool, thanks, and stores it to an SD card. And then we can use one of these little guys. This is called a Proxmark 3. This is just, the card just sits right on top of this plastic. That's real copper wire, and it reads the card. And then, it then can write to the card. So we can have like a bunch of blanks, come back, put in our SD card into a laptop, connect one of these up, and just with a command line tool, start writing the cards that we picked up off of people to blanks, and then walk up to the door and read just like that person. Because it'll have the same card number and the same bin as the card that was read. So again, just taking apart its pieces, looking at exactly how it works and going, oh yeah, we can just kind of do the exact same process. We're just going to do it in a weird way and end up with a working key card. Another good example is typically what's referred to as a rubber ducky. They are actually sold under the name like Rubber Ducky by Hack5, but you can also just get like a teensy board. The whole concept here is that it looks like a USB drive. It doesn't look all that conspicuous. You probably have heard like, hey, don't plug in weird USB devices into your laptop or things like that. And maybe at work they actually have that locked down, where they don't allow USB mass storage because they're worried that someone might plug one into their computer and open up a malicious PDF or try to execute something that is malicious. But what the rubber ducky does is, again, just looked at that pieces and said, well, you can't shut off the USB controller because we all want to use USB mice and keyboards. So what if we had a thing that was malicious and did stuff that we wanted it to do, but it identified itself as a keyboard? Well, it won't work then to show up as mass storage, but it will show up as a keyboard. And Windows, OS X, Linux will all happily accept anything that says, I'm a generic USB keyboard. It'll load up the drivers and go. So what can that do for us? Well, keyboards can type, right? Oops. I'm going to get back to demo in a second. And what it does is, since it's a computer, it's a little teensy board, it can type at superhuman speeds. So think of all the commands that I might want to run on a computer that I have access to, but I only have a few seconds. Maybe I distracted a receptionist, or someone left their computer unlocked in a coffee shop, and you might only have like less than a minute to have access to it. Well, it'd be really handy to be able to type with perfect accuracy at superhuman speeds. And these things actually even work on Android phones. So just with a little adapter to mini USB, you can plug in an Android phone, and Android has basically like Windows, like keyboard shortcuts. So you can actually even use one of these to try brute forcing lock screens on Android phones, or having it run commands if you find one unlocked. So I want to show you a quick demo of how this works. Go over here to my Windows box, and so this is the teensy board. It just looks like a USB drive. I took it out of the case so you guys could actually see the board and how big it is. It's got a little SD card in it. And actually, I will show you. So this is actually a rubber ducky. And the neat thing about the rubber ducky is that they do run on what they just refer to as ducky script. So this is effectively what it's going to do. It's going to wait 3,000 milliseconds when I plug it in. It's then going to run Windows R, which opens up the run command. It's going to run notepad.exe and do some stuff. So let's give it a second. There it goes. So obviously I can't type that fast. My hands are off the keyboard. It's just typing for me because the computer thinks it's a USB keyboard and that there's a human at the controls. So the neat thing about this is that while this is obviously going to take a few more seconds, with things like malicious PowerShell commands or malicious terminal commands on Linux, whatever you can imagine that might take just a few seconds to type out, this can be done in, I can get a backdoor onto a computer in like less than 3 seconds with one of these. There are mitigations to it as far as like actually on the network side of what might work, antivirus and things like that have to be taken into account. But in general, these kind of things can be amazing if you only have access to a computer for a few seconds. But they do have to be unlocked. So, which is why, again, if you're at a coffee shop or things like that, it is really important to say, like, hey, make sure you lock it. Even if you think I'm only going to walk away for like 2 seconds, someone might come over and put ASCII art on your computer, or worse. But so that's that's what the ducky can do. They're pretty cool.
My coworkers would Beaverize your computer.
Yes, exactly. There are ducky scripts out there you can get to rickroll people to have that come up. There's one out there that I refuse to even try because I don't want to go through the anguish that it would be to revert it. But there's ducky scripts you can get out there that will set like mouse speed to 1, reverse right and left click, like reverse like flip flop everything, and that takes like 2 seconds for it to run. It's just some Windows commands, but you can get up to a lot of trolling with these. But also on the other hand, you can do these for really good stuff. Like I know of some like sysadmins or IT people that they don't want to keep installing printer drivers, but they know like, well, we have it on this. Rather than running a script and having the user run it, I'll just walk up to their machine, say, okay, you need the new printer, plug it in, 5 seconds later they have the printer driver, everything's good to go, and they're done. So this sort of like hacking can be, in circumvention of typical ideas of what a USB drive is, can be used for good, trolling people for laughs or for evil. So we do have a little bit of time, so I thought I'd just, I can't get into too much detail, unfortunately, but just give you an idea of how some of these tools were used. This past week, I actually had to fly from across the country into Cleveland's airport, even though I'm actually from Michigan, to attend CodeMash because I was on a red team engagement. So what that meant was that I was brought on site to essentially do a penetration test, but I was told, like, we're not going to give you access to the building. We're not going to tell anyone that you're here. We're not going to tell anyone that you're allowed. Like, I'm, by all intents and purposes, I'm one of you. But the only thing that makes me different from anyone in this room in that situation is I have a signed contract that I basically have to keep in my back pocket. That is my get out of jail free card, quite literally. It's signed from, like, by their CTO that says, please, if this person presents this to you, call me and we'll straighten this out. Don't take them to jail. And that's the only difference. And otherwise, I have to figure out how to get into the building, how to get access to the network, and basically try to, I hate to say do as much damage, but do as much as possible, try to get as far as I can. And in this case, I was there with there's two of us, and I got there on late in the evening, and I went there and I kind of scoped out the building. I looked at the entrances and exits. I did, kind of all the, like, cliche things you see in, like, any heist movie or things like that. Took my pictures and went back to the hotel. The next day, I took that card reader I mentioned. I put it into a messenger bag. I wore, I kid you not, a Mr. Robot jacket and a hat, and I walked around that building waiting for anyone to try to approach me. I rode the elevators up and down. If people saw me, I just, my only pretext, I didn't have to weave a story. I was irritated white guy with a phone. I stood there kind of grimacing at my phone, typing. I just answered emails and tweeted and talked on Slack while I rode elevators around and walked around their floors. And people just assumed I was a visitor or someone that was probably not, in a good mood, and they were just going to let me walk by while I picked up, like, cards, that were on their belts and things like that. Went back to the hotel and dumped those onto onto a computer. My partner wrote all of them to various, like, blank hid cards that we had. I went back, and this time, rather than walking around the reception area and things like that, I walked into their, like, finance and HR, just badged myself in and walked around there. And then we just kept doing that until I eventually had badge access to all of their floors, to the executive area and things like that. And was never questioned because no one wants to confront an angry guy walking around that just is, they probably assume is from IT or something. He's just, white guy I've never seen before, walking around with a messenger bag. She probably works here. And went back in the evening and badged myself in. And we walked around, took pictures of all the Post-it notes with passwords on the sides of monitors, lifted up monitors and keyboards, found all the passwords there, went back to the hotel, and then walked over, and I'd actually done this in daylight while I was walking around even without badge access. I had installed a back door. I just basically a little device, like a little Linux computer, like the size of a couple iPhones sitting on top of each other. I plugged into an open network jack and gave power. Went back to the hotel, connected to that, and started using the usernames and passwords we had found to move around the network and do stuff. And then eventually kept escalating my privileges on the network until I was admin of their domain. And that's effectively what I do, and that's how I did it. There was really nothing there that was all that spectacular. I walked around. The only thing I did was I had enough confidence to walk around and not freak out that I was walking around in a place I definitely should not have been, and it could have been questioned at any point, because really what gave me the confidence was no one was going to question me. Because if you ever sat through security awareness training and had someone tell you, look, you should really talk to people that you don't recognize in your office and find out why they're there. That's why. Because that really does happen. And while you might occasionally run into the person that's like, oh, I'm new today, and they might actually legitimately be new, then just talk to them. You don't have to be a jerk about it, but question them, find out why they're there. I ran into someone. Actually, we both just came face to face while I walked into a bathroom, and he held the door open for me and apologized. We'd never seen each other before. So, this is we actually ended up not even needing the rubber duckies, but we had those with us. We found unlocked computers while we walked around. And eventually, as part of these engagements, we tried to push the limits to see, all right, we've kind of done everything. It doesn't matter if we get caught now. Let's see how far we could have gone. Like, I was walking up to the receptionist computer and typing on it, running commands and taking pictures. I was walking around filing cabinets labeled like tax returns and taking pictures. And people maybe saw me and just was like, whatever, that's weird. Like, no one asked me why I was doing that. Things like that. So we try to push it as far as we can, and it doesn't always go that way. But in this case, it was probably just a whole bunch of nice people that were busy and doing their own thing and didn't want to bother me. And we're like, he probably has a reason for doing that stuff. Whatever. He's probably from IT. That's why he's on that computer. And so all this stuff that we talked about today, it's important just to remember all that. Like I said, it can be really exhausting if you're constantly thinking like an attacker and you're like, well, what if I did this? I need to double check the config. It gets really tiring. But always keep that in the back of your mind when you're looking at something and trying to figure out a problem, that both even if you're just trying to problem solve, trying to look at the pieces of it and use this kind of mindset and what we've talked about today can help you solve a problem maybe in a creative way. But also if you're trying to figure out if something's secure or not, or if something is a good idea or not, trying to apply some of these principles can be really, really helpful. And might end up saving you in the long run. So I think we have actually like 11 minutes since these are full hour sessions. So any questions or comments? Yes.
So have you ever had any issues with like smaller businesses, like ones where it's family owned and like you can't do something like you just said because they all know each other? So if they see
that can definitely be a problem. Typically, to have people come on site and do it is honestly would be cost prohibitive for a small business like that. So I don't think they probably do that a lot. But to give you kind of a different example, I have heard from people I work with who have done say like this kind of work in like Hawaii, where a lot of that is family owned, even if it's a larger business on the island. But also, if you're a white guy walking around Hawaii and you walk into the back of a shop, like you stand out really, really, really well, and people will question you because you stand out so much. So definitely taking into account the your surroundings, what you're walking into, can definitely cause problems for you if you might not supposed to be there. People will definitely know. Yes.
Do you know what the remediation plan is from that pen test you just shared with us? Have any idea what they're going to do?
With that one, so they don't own the building, so there's a lot of security features that probably could have kept us out. Like for example, we ran into certain badges could only work on certain floors, but they had access 24 hours a day. So like the chance that someone from finance is really going to come in at like 1 a.m. to have to do some tax returns real quick is probably nil. And the idea that you might be able to just deal with it on a case-by-case basis if suddenly someone wakes up and goes, my purse is, my passport, I'm going on a trip tomorrow, my passport is totally on my desk. You'd probably work with security or something like that to get that worked out on the odd cases. But things like making sure that people are only accessing the office when they should be. There was accounts that I was using like well after hours. There's security monitoring that can be done and things like that to see why is someone from HR active on the network at 11 p.m. That's kind of strange. There was actually even users that I was using that when we checked their username and password, it was because they had a desktop. So it's pretty clear they're not even going to be working from home. And there I was using their accounts, late at night. So things like that can really help. And then even just simple controls non-technology wise, like asking people why they're there, being attentive, things like that. Like I didn't have a badge or anything. I was just walking around. No one asked me to identify myself or even said hello to me. Like that could have tripped me up at the wrong moment. Someone saying hello to me and asking me a question. They didn't even necessarily have to come up and be like, why are you here? And be confrontational. They could have just engaged me in conversation. And that could have, at the wrong moment or the wrong timing, or if I was unprepared, could have, revealed something. Anyone else? Yeah, yes? For which, I'm sorry? Oh, yeah. So if you go to, which one? This one? Sure. Yeah, if you look up Beef Framework, it should be one of the only hits that you can find on Google. And I usually post my slides up to my GitHub as well, if you want to reference back to them. And I have, I believe, recorded this, so I plan to put it on YouTube if that worked out. Yeah.
How close did you have to be to clone those RFID cards and do things like the wallets or something to protect against,
Yeah, definitely. So like that card reader that I was using has like a range of 6 feet, but that's like when it's hooked up to power, like in a garage, and with the idea that like you're driving by or something, and it's like there's air between you and the reader. So in reality, for us, it was probably more like 3 feet, but even then, that's still like plenty of room. But yeah, like the human body, things like that, definitely start to interfere with it. People have phones. There was definitely plenty of times where I was like as close as I was to this, to this podium to someone. Like even with my the reader through my bag, I had people bump into the reader with their badge, and I didn't get a read. So like yeah, just random interference and things like that can definitely be a problem. We didn't have it working at the time; it had kind of broken down. But there are tools you can get that will, for example, send through Bluetooth, just send you a note, give you a little push notification, like, oh, we got to read. So you can be a little bit more like, oh, okay, my phone just buzzed, so that worked. But otherwise, it's a bit more guess and check. Like I walked around there for a couple hours, and then we went back to see, like, well, hopefully we got some.
And is there any way to protect the cards, or like do the sleeves of wallets work to lock those things?
There's definitely ones, I've seen people who buy the wallets just to see how well they protect things, and some just don't at all, some do. There is definitely stuff like that. There's also just different types of cards that can make it more difficult for it to read. There's cards that are literally just I'm RFID, I give up the bin to whatever asks, and those are way easier. So there are ones that can cause some complications. Yes?
Have you done anything with security in automobiles?
I have not. It's something I've messed with a little bit, just on the side. But yeah, the car hacking stuff is definitely very cool. But I haven't done anything like any myself. Yes. I think we had the area that I was walking around in was not as well. There was offices, but they were kind of behind a badge door, so that I couldn't walk around in those at first. I think I got 5 or so walking around kind of the reception area and riding the elevators. But I mean, by the end, once I got into the offices proper, I think we used up all of our blank cards that we had. It was like a stack. Yes.
Have you ever been in a red team test or penetration test where someone was surprisingly well secured? Like you went in, you tried and you're like, oh wow, you're implementing this.
I have not, as far as the red team testing, but for penetration testing, there's definitely been surprising moments where I try to do something and it's not working, and talk to them later and they're like, oh yeah, no, we blocked that, but because of this, or even just totally coincidentally, oh no, how does it work? And I explained to them oh, actually we shut that off because of this other totally random thing. Oh wow, you didn't even realize you'd shut down a whole attack vector because. So there's definitely, that's one of the fun things about the job, is that it's not always cookie cutter of how it works out. Sometimes it's just you try something that you think is going to work and it just doesn't. And at that point, then you have to troubleshoot well, did I do it wrong? Was it the tool? Was it my connection? Or is it their side that? So that makes it interesting for sure. I think I could probably do 1 or 2 more questions if anyone has. Yeah.
Can you just switch back to your opening slide with your GitHub and all that on it?
Yes.
Thank you.
There we go. What? Any? What? I have not. A friend of mine was almost arrested a couple nights ago, though, because they forced open a door near the end of an assessment, and security responded, but they They explained things, and the cops were not called, but that was that would have. Any last question? Yeah.
As far as brute forcing or username and passwords, try to bypass the login. A lot of systems have timeout set, so beyond 3 or 5 failed attempts. Is there a way to still bypass that? Or
So.
a good way to protect against?
No. Brute force protection is definitely something I would recommend. There is still a couple of ways you could get around that. I'm not necessarily around it, but you can work with it. So, for example, some brute force protection will respond back. Like it might send back a response that this is like invalid password, and then when you get to the 5th try, it says you've been blocked for 5. Try again in 5 minutes, and it always says that. So if you can see that, and that's in the HTTP response, you could set up your brute force to either figure out the timing and like really slow it down. Like I only try once every 30 seconds, and that it like resets after 30 seconds or something like that, so it never locks me out. Or you could keep doing it, and then when you see that response, pause for 5 minutes, resume, pause for, it would definitely take longer, which is why it's still an important control, but if it can give no indication you've been blocked, that's even better. Because then you don't know if you've been blocked, you don't know if it's still failing, and you can't figure out the timings at that point.
And that would also affect usability for people.
It does, yeah. So that is the downside, is that then you're like, I don't know, and then your sysadmin is like, well, yeah, you were locked out. It's like, oh, I had no idea. So it's definitely there is a trade-off there for sure. Yes.
What's the most common attack you've seen against like mobile apps or mobile phones?
Against mobile apps, the one that comes to mind would be like APIs. Is that not securing the API properly, because a lot of that's just API calls. Like the one example that comes to my mind every time is like the I think it was early last year was the Tinder API. They did all their API calls over HTTP, and you could go to a coffee shop and capture API calls on the Tinder app, and it had the key in it was unique to the user. So if you grabbed that, you could start just like sending commands as the user. So, it was, you had to do it blindly. You could be like swipe, like whatever. And just, not really like a huge problem. I don't think it was for them, but stuff like that to start messing with the APIs. All right, I think we're out of time, but I'll be around if anyone has any other questions. Thank you.